Good morning. Welcome to the Managing Drought in the Southern Plains webinar series. I'm Margaret Boone, Program Manager with the Southern Climate Impacts Planning Program, and I will be the moderator for today's webinar. Mark Schaefer, SCIP PI, will be managing our webinar. This information is brought to you by the Southern Climate Impacts Planning Program in association with NOAA, NIDIS, and the National Drought Mitigation Center. We also greatly appreciate those of you who join us in this webinar series and recognize the valuable time that you commit to participating. Today's webinar is entitled El Nino, What's Next? Presenters include John Nielson-Gammon, Texas State Climatologist, and Victor Murphy, National Weather Service Southern Region Climate and Co-op Services Program Manager. John Nielson-Gammon will be discussing the current El Nino, how it compares to past El Ninos, whether the dry midwinter weather is unusual during an El Nino, and what all of this means for the rest of the winter and spring. Victor Murphy will discuss seasonal forecasting techniques, the tendency for stronger El Ninos to transition to La Niñas, and what the current projections show for the fall and winter. You may ask questions or make comments at any time through typing in your chat box. We will address questions at the end of the presentations, and we will also put up a list of resources. I would now like to turn it over to John Nielson-Gammon.
Okay, thank you very much. I'm going to be talking about what has transpired in broad terms over the past few months, as well as what's going on with El Nino right now, and what that means based on historical El Nino events. I'll wrap up with a brief look at the shorter term forecast. Next slide, please. So the past month, rainfall across the southern United States has been a bit uneven. In Texas, we've been going through a period of very dry weather. Lots of places haven't received any precipitation in the past 30 days, and some of that extends across southern Oklahoma into western Arkansas as well. However, on the other side of the region, Mississippi, for example, places have gotten over 10 inches of precipitation along with the severe weather that goes along with it. So the last month, dry to the wet to the east. Next slide. If we look back to 3 months at the departure from normal, we get a different picture. Northern Texas and Oklahoma are the wettest on that time scale, whereas Louisiana over the past 3 months is down well over 5 inches. Next slide. If we look at the past 6 months, different picture entirely. Mostly above normal rainfall over that long a time scale. So we're looking at also a lot of this is the variability from month to month that you're always going to get during the winter time. So I don't think it's appropriate to panic yet if you're going through the current dry weather stretch. Part that's because El Nino is still going strong. Look at the next slide. You can see a plot of the intensity of El Nino and a few of the stronger El Ninos of the past, looking a year before and a year after their wintertime peaks. The current El Nino is the thick black line, and you can see it's still running third strongest historically, and it's going to at least maintain that record. There's right now very little chance that it'll actually would intensify enough to break the record for the most intense El Ninos back in 1982 and 1997. And you can see based on the track record of the past, all of the other strong El Ninos have begun weakening sometime between the beginning and end of the spring, and pretty much have weakened to moderate to neutral to even possibly La Nina by next summer, as Victor's going to talk about later on. Next slide, please. Want to look at the tropical Pacific Ocean temperatures. This is a plot of temperatures from New Guinea on the left to Ecuador on the right, and going down about 1,500 feet. So the orange warm colors at top are the warm water, which is normally deepest out in the western Pacific to the left of the diagram. But with this very strong El Nino, the deepest warm waters actually moved to the central Pacific. That's affecting the thunderstorm activity and consequently all the global weather patterns. So that's indicating a nice strong El Nino, but the fact that the warm water is so shallow out west, and the fact that that shallowness is going to tend to spread from west to east over time means that this El Nino is pretty much on its last legs and is soon going to start weakening. Next slide. Next slide, please. Okay, so if we look at the two strongest El Nino events in the past, going forward, we see something essentially alarming for most of the southern United States. They've tended to be as much as 3 to 6 inches of rainfall short of normal during that 3-month span. But if you look at the next 6 strongest events, the ones that don't quite make it as strong as this one, the next slide, you see almost the opposite picture, tending to be wetter in the western part of the southern plains and then dry up in the Ohio River Valley. Next slide. Going forward, those next 6 are very wet historically in the June to August time frame. Next slide. On the other hand, if you look at the 2 strongest El Ninos, they ended up being very dry across most of the southern United States. Next slide. So as a result, we've got a very clear picture. This picture, unfortunately, actually had information on it on my original slides. Hey, there we go. There's some of it. Okay, let's go with that. So over on the far right, we're looking at the accumulated rainfall so far for this year, starting in October. October is the red bar, then November is the green bar, and so forth. And the plot immediately to the left of that, so second from the right, is what's happened on average during the 12 strongest El Ninos on record. You can see we're above schedule right now. Even if we got no precipitation at all in Texas, this is just for Texas, we even got no precipitation at all for Texas in February, we'd still be above the average for El Ninos. And let's see, the 5th bar from the right is normal. So we're well above normal even if we didn't get any precipitation in February or March. So the basic problem is the rainfall is not being evenly distributed in time. We had very wet late fall, and we had a fairly dry winter. And as you saw for the spring, it's still jury is out as whether it's going to tend to be dry or wet. If you go with the majority rule, which is the 6 out of 8 strongest El Ninos, it's tended to be wet across all of the southern United States during the next few months. But as you saw, it's possible that we'll have a dry year in there. The 2 bars on the far left in this diagram are the 2 strongest El Ninos. You can see they tended not to be as wet as other El Ninos that are plotted on the diagram. But even at that, they weren't dry for the entire March, April, May period. They both produced decent Marches. One of them was fairly wet in May also. Of course, this is just one tool for forecasting seasonal precip, looking at history. And that tool doesn't work real well when you're talking about extreme events like how strong this El Nino is, because there aren't very many that have been like it in the past. So Victor's going to talk about some of the other techniques that get used in the resulting forecast. Next. I'll just briefly show you what the Climate Prediction Center came out with this morning. For the seasonal forecast for precipitation in the spring, they're going with the what we've seen historically for the majority of strong El Ninos, which is above normal chances of precipitation, enhanced chances of above normal precipitation across most of the southern United States, except for, say, Arkansas, Tennessee, and nearby areas there. Next slide. And that pretty well matches that 6 moderately strong El Nino composite. Next slide. And it doesn't match what we saw in the 2 strongest ones. So there is unfortunately always that danger that this is going to match the stronger El Ninos rather than the ones that weren't quite as strong. Next slide. This is a typical summer outlook for precipitation from the Climate Prediction Center, especially when we expect El Nino to be weakening, so there's not going to be a strong driver of unusual weather this summer. So pretty much going with no particular reason to expect above or below normal rainfall. There's equal chances of both happening. course, with temperature. Also, there's very little reason to expect something in particular to happen, except for the fact that we've had global warming for the past century. So next slide. This is basically your global warming forecast. We have enhanced chances of above normal temperatures everywhere this summer. Next slide. Now, finally, just a short-range forecast. The next widespread precipitation event looks like it's going to be the beginning of next week, stretching from Sunday to Tuesday. This is the accumulated precipitation across the southern United States. Not particularly good for the Panhandle in western Oklahoma, but the farther east you go, the better the chances of rainfall. With lots of places should get more than an inch of rainfall out of this. So those who are lucky enough could see an end to this short-term dry spell, and as a consequence, reduced chances of wildfire and improved conditions for getting crops into the ground. Next slide. And the weather pattern looks like it's changing also. This is the forecast for the jet stream in a couple weeks, and you can see with the colors a strong jet stream going across Baja California from the Pacific and then heading down toward the Gulf of Mexico, which means active Gulf of Mexico with lots of precipitation events if this holds true. Next slide. Of course, it is 2 weeks out, so there should be a question mark attached to that. But to show you how significant a change this is, next slide shows the current pattern. You see a big ridge over the central United States and basically nothing coming in toward us from the Pacific. So if that holds true, and the models have been consistent with it for the past several days, it means that this extended dry spell we've seen in most of January and February is going to transition into a much wetter March, which also would be consistent with the longer range seasonal forecast. Okay, that's all I have. I'll turn it over to Victor with just a summary. El Nino is still going strong, and probably that means above normal rainfall for the next few months, starting next week, and hopefully that extending on as we start getting more storms coming in from the Pacific.
Thank you, John. Now I'm going to turn it over to Victor Murphy, who's going to talk about Beyond the El Nino.
Okay, thank you, Margaret, and good morning, everyone. John did a wonderful job of setting the stage, I think, through springtime, which would be the March, April, May time period, which is pretty critical, very critical actually, because April and May are two of the wetter months across the southern plains, especially Texas and Oklahoma. So with more uncertainty, I will take a stab at the summer and just a quick stab at the summer, and also look ahead into the fall and the winter. So question is, will we have Los Niños, plural, back-to-back El Niños, revert to La Niña, or La Nada, which basically is nothing, going forward to the end of 2016. Next slide, please. So in my presentation, I'll do a quick summary of the various long-term forecast techniques, a review of how previous very strong El Nino events in one cold season, what they look like 1 year later, and John's going to touch upon that a little bit, and also some best estimate scenarios for the fall and winter of 2016 and 2017. Next slide. John talked about El Nino, La Nina, etc., and these are routine changes in sea surface temperatures which occur in the equatorial Pacific Ocean, and they wax and wane. You can see the variability involved. Basically, when the sea surface temps along the equatorial Pacific Ocean are colder than negative 0.5 degrees Celsius, we call it La Nina. When they're warmer than plus 0.5 degrees Celsius, we call it El Nino. You can see on the far right of this graph, we're in a very strong El Nino right now. This graph goes back from 1982 through present. You can see, as John pointed out, there was two historically very strong El Ninos, 82-83 and 97-98, which compare favorably to this one, and others which are not quite as strong but still ring the bell as being strong by the fact that they are 1.5 degrees Celsius or warmer. You can see it's not too uncommon to go from El Nino to La Nina, as these graphs show. Next slide, please. So as far as using different forecast techniques, certain geographic regions of the U.S., especially Texas and Louisiana and the Gulf Coast and Florida, actually the southern U.S. is sort of blessed, if you will, with having a very strong correlation between El Nino and La Nina during the cold season. Basically, during El Nino events, Texas, Louisiana, and the Gulf Coast, and sometimes up in southern Oklahoma, tend to be on the wet side, and the opposite is true during La Nina. La Ninas tend to be drier than normal during the cold season. So as far as forecasting goes, dynamic models are out there, which with increasing accuracy, which can forecast both the sea surface temperatures, or SSTs for short, in the equatorial Pacific, and then link that to expected long-term climate and weather conditions, 3 months, 6 months, 7 months later. And or you can do composites, which allow you to look at certain analog years with similar conditions, like John did, as far as looking at those two strongest El Ninos, and then take a peek at the 6 other strong El Ninos. So composites allow you to look at the analog years with similar conditions and then make forecasts going forward based on this. So I'll just take a quick peek at looking at some of the results of both these methods. Next slide. So this is this graph here is from the International Research Institute at Columbia University in New York City and the NOAA Climate Prediction Center. And basically it shows, this is a plume diagram, it shows the forecast sea surface temperature anomaly for the a certain region of the Pacific Ocean along the equator. So on the top left, you can see where we're at right now in the very upper part of the graph. We're in the strong El Nino. And then I have drawn, if you look at plus 0.5 Celsius, you can see all the models, as John pointed out, consistently cool this event off and have the waters in the equatorial Pacific cooling off, some quicker than others. But the bottom line is, like John said, this El Nino is on its last legs. The only question now is how quickly does it cool off, or do things cool off in the Pacific Ocean? And the thicker yellow line there is the average of all dynamical models. So looking at that, you can see basically temperatures revert back from El Nino towards neutral conditions, which is between negative 0.5 and plus 0.5. Conditions revert back to neutral. It looks like about the May, June, July time frame, basically sometime this summer. And the question going forward is, well, will things cool off even more? And will we revert back to La Nina conditions by the end of the year? And you can see the models do start to diverge quite a bit as you get further out in time, which you would expect. But the average of the dynamical models does take this event down to about negative 0.5 or negative 0.6 by the end of the year, which would put us into weak La Nina conditions. Of course, it could be stronger than that or colder than that, or we could end up somewhere in the middle, which would be La Nada, or basically into neutral conditions. Next slide. This graph here shows the latest forecast from the same group at IRI and CPC. Basically, it's a probabilistic forecast of a consensus of the forecasters showing, what will be the most likely scenario going forward in time. So in both the graph at the top and the table at the bottom, you can see right now, through February, March, April, basically 100% chance of El Nino continuing and 0% chance of La Nina. However, as we move into the May, June, July time period, you can see the green graph, which is neutral conditions, now is slightly higher than the El Nino probability. And sure enough, looking at the table, basically a 46% chance of neutral conditions, 44% chance for El Nino continuing. So we should move into some neutral conditions sometime this summer, either not early summer, by late summer. And then as we go forward towards the fall, you can see that the probability of La Nina actually is now the highest probability. So there's a 50% probability, at the very bottom left, have it highlighted, basically 50% probability of La Nina conditions developing by the September, October, November time frame, which would be basically the fall of 2016. Next slide. This slide should load also there. Okay. Maybe not, but anyway, basically, of the 6 very strong El Nino events since 1950, 3 of them 1 week later, taking the peak of the El Nino, where were they one year later? Looking at a snapshot, basically 3 of those 6 were La Nina conditions 1 year later. So that also jived perfectly with the 50% or so probability of us being in La Nina by this time next year. Next slide. Okay, this here is a composite forecast. I looked at those 6 strong El Niños, and what did the following winter look like? And this is December through February, so this would be the forecast for December through February as for 2016, 2017. And you can see not a whole lot going on, quite honestly, surprisingly blank map, but it is sort of La Nina-ish looking, if you will. The wetness in the Pacific Northwest is pretty common with La Niñas. You can see if there's any signal here across the southern plains, it is a small tendency or small flip or a small an increase in probability of having drier than normal conditions across the Texas and Oklahoma and Arkansas for next winter. So, but no part of the southern plains has a probability of having above normal precipitation for next winter, at least based on this composite technique here. Next slide. Looking at some of the models here. This is the European model. This is their forecast for the June, July, August time period, which is pretty much middle of summer. This sort of touches upon a little bit what John talked about. You can see a strong tilt towards warmth in the Atlantic Basin as far as sea surface temperatures go. Gulf of Mexico and the entire Atlantic Basin. Temperatures are forecast to be as much as maybe 1 degree Celsius warmer than normal. And you can see the beginning signs of the La Nina developing there right along the equator, 0 degrees north here, west of South America. And this is for the June, July, August time period. Next slide. So I just want to show it real quick, and this is the precipitation forecast that goes along with that. You can see the Gulf of Mexico has a little bit of a tilt towards wetness, and not much else in our area. So I think this jives pretty well with what John showed. Summertime, pretty much not a very strong signal either way. Conditions expected to be until neutral, and not a very strong probability one way or the other as far as enhanced rainfall goes. Although with those strong sea surface temps, with those much above normal sea surface temps, and depending upon how quickly the La Nina develops, there could be a little bit of a tilt towards enhanced tropical cyclone activity in the Atlantic Basin for what that's worth, especially compared to the last 2 years, which have been very, very quiet. Next slide. And this map here is from the NWS Coupled Forecast System, which is a dynamical forecast based on the sea surface temps and other parameters in the call it a coupled system because it looks at both sea surface temperatures and the atmosphere to go forward and make a forecast. And this is August, September, October, and you can see in general still not really much of a signal. Pretty much sort of if anything, perhaps some pockets in West Texas and New Mexico still wetter than normal. Parts of the eastern part of our region drier than normal, but still not a real strong signal either way. So looks like the summertime into the early fall, things are sort of a mixed bag. Next slide. Here are the CPC forecasts going forward for the fall and for the winter. On the left is the forecast from January 2016, last month. On the right is the new forecast, which came out today. This is for September, October, November. And you can see CPC did, this is consistent, I think, with the slides that John and I have been showing. At least into the early fall, looks like there isn't really very much of a signal. So you can see they did cut back quite dramatically on their forecast of increased chances of below normal precip in the fall across the East Texas, eastern Oklahoma, eastward. They did show the dryness there across 4 corners in New Mexico. Next slide. And this is the wintertime outlook for CPC from December, January, February of 2016, 2017. On the top is the temperature probability. You can see a pretty strong tilt for increased probabilities of above normal temperatures for the southern U.S. But the main thing I want to point out would be the bottom graph there, bottom slide or map, which shows the pretty strong tilt towards increased probability of below normal precipitation for basically all of Texas, Oklahoma, and the entire Gulf Coast into Florida. This is classic La Nina. This is La Nina 101. And so that's what things look like right now, and that's, once again, consistent with everything we're looking at. Next slide, please. So in summary, the odds would appear to be at least 50% for the current El Nino to flip to a La Nina event by the end of 2016. One wild card I do want to introduce, I talked about it briefly, will we see will we revert back to a more active Atlantic Basin hurricane season? Of course, that would be a huge wild card as far as summertime rainfall goes. Probabilities are, if you have, say, above normal tropical cyclone activity in the Atlantic Basin, odds are you probably have these near normal to perhaps above normal precipitation. Then going forward from there, the tendency for below normal precipitation should start manifesting itself in the fall across the southern plains. The question is, would it be early fall or late fall? And I will point out that the most recent significant drought, which occurred across Texas, Oklahoma, and parts of New Mexico, began in October of 2010, concurrent with La Nina development in 2010, which actually lasted through 2012. So that's pretty much all I have. Next slide. That's my contact information in case anyone has any questions at all.
Thank you, Victor, and to John. That was some really great information, and I've been watching the comments come through on the chat, and there's really been some great questions asked and some really good responses so far. So now I'll open it up. If there's any additional questions or comments that you'd like to ask, you can put them in the chat box, and I'll open it up, or I can read it, and Victor or John can respond. And if we go to the next slide, there's a list of some drought resources available, and we'll leave that up while any additional questions come through. As a reminder, presentation materials today will be posted to our SCIP website, and there'll be a 2-page PDF summary that'll be prepared and then posted, and I'll send out an additional notification once that is available. This webinar is also being recorded, so that should be up later today or tomorrow on both the SCIP YouTube page, and then it'll be on our SCIP website as well, which is southernclimate.org. Victor or John, do you guys have anything else you'd like to add?
Real quick, I'll take a stab at answering one of the questions here. I think Mark Schaefer asked, is the Pacific Decadal Oscillation still running positive? What effect would this have on La Nina? I believe the new value came out for the PDO for for January of 2016. And I think it was plus 1.5. So the Pacific Decadal Oscillation is still running very positive, has been for about 2 years now. And that would be, I think, actually a negative for La Nina to develop, or for the La Nina, or for the strength of the La Nina, if that continues. And I'll let John go from there.
Yeah, in a sense, the PDO, positive PDO and El Nino tend to have, in a broad sense, similar impacts on the southern United States. So combine a positive PDO with a La Nina, those sort of cancel each other out. And so you don't tend to have the big anomalies that you get if both of those were going in the same direction at the same time.
Great, thank you. Mark Savoda asked, can either of you speak to cold Pacific, warm Atlantic, and what effect that may have on future drought development?
I'll take a crack at that one. It's not just each ocean sort of acting independently on the weather and things add up. You get these combinations that can take place that have particular impacts. And one such impact is when the tropical Pacific is colder than normal, like it would be during a La Nina or a negative PDO, and the northern Atlantic Ocean, by which I mean basically everything north of the equator, is running relatively warm. And that's been shown historically and in climate models to tend to lead to drier than normal conditions across the central and eastern United States, especially in the summer and fall. There's an awful lot of variability from year to year in summertime rainfall, so that's not a really good tool for making a seasonal forecast, but it does tell you whether you're in a particular drought regime or not. And for the past almost 20 years, at least the past 15, we've been in that sort of cold Pacific warm Atlantic pattern, and we have been seeing frequent droughts in the southern United States, with that pattern presumably contributing to it. With the Atlantic possibly switching cold, as it has been the past year or so, and the Pacific now running warm, as we see with a positive PDO, I'm sort of waiting to see whether those patterns stick, whether they actually are there for the long haul, or whether it's just a random variation that's going to flip back. But if it does stick, if we have lost that cold Pacific warm Atlantic pattern, that would mean that we may be out of the drought cycle that we've been stuck in for the past 15 to 20 years, and be going back to more like conditions we saw during the 1980s and early 1990s, with generally above normal rainfall.
Thank you, John. That was a great answer. We also have a question from Benjamin Diamond. Could we review how this El Nino has compared to the 82-83 and the 97-98 El Ninos?
Yeah, that was one of the things in the slide that I didn't have time to talk about. Basically, at least in terms of consequences, they've been relatively similar in the sense that we're seeing near normal rainfall patterns, and the tendency for the jet stream to not actually have sort of a strong tendency to go toward California, but actually be broader across the Pacific coast. But I haven't been following the specific, say, week-to-week patterns to say how the evolution of the weather systems has been compared to those years.
Thank you. If there aren't any additional questions coming in, I'll just say again, thank you so much to John and Victor for great presentations. And thank you to all who logged in and participated. We had some really good conversation going on through the presentations as well in the chat box. So I really appreciate you taking the time to log in today and to be a part of this webinar. I'll remind everyone, again, this is being recorded, so it'll be up later on our YouTube channel and our website in case you want to send it on to anybody or just review any of the material. So thank you all for your time today, and we look forward to continuing this conversation with you in the future. Thanks.